Hi, everyone. Thanks for joining. We'll give people just one more minute to hop on. All right, welcome everyone. Thank you for joining. My name is Adrienne Underwood and I'm the Communications Director for PSC Healthy Energy. PSC Healthy Energy is a nonprofit research institute that studies the way energy production and use impact public health and the environment. Today, we'll be discussing the findings of a new study called Home is Where the Pipeline Ends. As a participant, you'll be muted for the presentation, but you may drop questions in the chat function and we will get to those at the end of the presentation. My colleague, Jacqueline Casale, is going to drop some resources into the chat now, some links to the studies and other resources for you. And I'm pleased to introduce our panelists. We have Drew McKanowitz, a senior scientist at PSC Healthy Energy and a visiting scientist with the Center for Climate, Health, and Global Environment at the Harvard T.H. Chan School of Public Health. Zainab Magave, co-executive director of Home Energy Efficiency Team, HEAT, and guest faculty at the Harvard School of Public Health and a guest lecturer at MIT Sloan School of Management. And we are also joined by Dr. Curtis Norgard, a senior scientist at PSC Healthy Energy and a practicing pediatrician. Thank you, Drew. I'll pass it over to you.
Thanks, Adrienne, and thanks everyone for joining today. So I'd like to start here with the familiar blue flame. Now, since we started this research study about 5 years ago, we've seen a reemergence of the study of hazardous air pollutants that are emitted when natural gas is burned. Now, the good thing here is that these pollutants go away when the flame goes away. Now, one of those studies, in addition to measuring pollution from burn gas, also measured natural gas leakage from unburned natural gas or unburned natural gas from stoves and ovens in our kitchens. And there were two really important findings that set up our study today. The first is nearly every one of the 53 stoves and ovens they measured was leaking at least a little bit. Now, some leak more than others, of course. They leak more when they're on, but they all leak. Now, second, the really important finding that sets up our study is that in total, 75% of the total leakage that they found coming from stoves and ovens occurred while the stove was off. Now, this is in part because the stove is off for most of the day, but it leads us directly into our research question. If natural gas is leaking in our homes, what else is in natural gas? So that's exactly the research question we set out to answer. And we found that natural gas that's delivered it to our homes that we use at our natural gas appliances contains numerous air toxics. Now, air toxics is a special EPA classification of air pollutants that are either known to cause cancer or other serious health effects. Now, there are currently 187 different pollutants on that list. We detected 21 of those in unburned natural gas at the point where we use it, including benzene, which we detected in 95% of our samples. Now, we focus on benzene due to its toxicity. It's a known human carcinogen. It can affect both white and red blood cells. At high enough exposures, it can lead to anemia and decreased immune function. And due to its toxicity, is strongly regulated by federal and state agencies. And that's really reflected in the low exposure limits. For example, the state of California has a recommended exposure limit of less than 1 part per billion. And of course, because it's a carcinogen, the exposure is accumulative and there's really no safe level. But I do really want to stress that the concentrations that we found are really low and are not a cause for immediate concern. But we do think they are certainly important given the widespread use of natural gas in our society, in our homes, a place where we spend 90% of our day, take 20,000 breaths. So we really do think it's something worth exploring more. Another one of the interesting findings was that we found significant fluctuation or differences of these trace gases across the Boston communities that we measured and over time. The over time piece was really interesting. We actually observed a wintertime peak. That is, the concentrations of these trace gases were 3 times higher in the spring, or 3 times higher in the winter than in the spring, excuse me, and we're up to 8 times higher in the winter than in the summer. So the other part of our research was really trying to figure out, okay, if we know there's a hazard present in natural gas, could we be exposed to it unknowingly? This leads us to asking the question, how often can we smell leaks? And to do this, we actually measured the odorants that are in natural gas. Otherwise, if odorants were not intentionally added to natural gas, it would be completely odorless. It is really our line of defense in terms of knowing or not if there's a leak in our presence. So we measured the natural gas odorants at the point where we use it, and we found that those natural gas odorant chemicals can actually vary a lot. Now, this is important, right? Because if this is the only way we can smell leaks, well, we really want the concentration of these odorants to remain constant over time. Now, of course, we also were able to show that there is enough odorant in natural gas at the point where we use it, that it met all federal and state odorization guidelines. But we also found a seasonal trend with the odorant levels as well. We found lower odorant concentrations in the wintertime than we did in any of the other seasons. Now, if there's less odorant in gas, there's a higher potential for a larger leak to exist without having a smell to it. So this is really important to think about exposure, which we'll talk about in a little bit. Now, this finding may also help explain how small leaks could exist around us without having a smell, without us able to detect it. Perhaps those small leaks in our cities and in our homes can add up and can lead to a large amount of gas that is leaked from cities, which has been reported numerous times now, including in Boston. So to combine these two findings, this is really the first time where we're thinking about leaking natural gas as not just a climate pollutant, but maybe also an air quality and direct health pollutant as well. But I do want to stress, this is just a hazard identification study. We did not measure leaks formally, we did not measure exposure, and really any impacts to air quality or health really require leaks to be present. They require an exposure route. And so, of course, we are recommending further study here. But what we can say is that any impacts from leaking natural gas would be additive to the already known post-combustion pollution, which we talked about earlier. And to contextualize this a little bit further, if we see in the wintertime we're finding higher levels of these air toxics in gas, higher gas usage because demand is rising, we spend more time inside during the winter, And depending on your heating system, there can be much less ventilation happening, much less fresh air coming from the outside, meaning that indoor sources of pollution become that much more important. The other interesting finding here is thinking about fossil methane or methane coming from natural gas as different from other sources of leaked methane. And the other way to think about this is we really are important. We really want to understand the co-pollutants that are in our energy system because they're really important for health and they're really important for policy. Now, I just want to quickly go through the methods, and because it is important to really show what we were doing here. So here's my colleague, Eric Labelle, taking a sample. And you can see here, there is a direct connection to a stove burner outlet going directly into a canister where we take a sample of unburned natural gas, we send it to a lab, an EPA certified lab, and it gives us information on hundreds of different chemicals. Now, we took samples all across Greater Boston, 15 different communities. We also sampled across the 3 major natural gas distribution companies. Those are shown in 3 different colors here. So overall, the black dots shown are the unique locations where we took samples. We sampled in 69 homes across 15 communities. We had 234 samples that we used in our final data set, again, across the 3 different gas companies, and we sampled across 16 months. And I'll just point out here that the lines transversing the Greater Boston area are the major pipelines of natural gas that flow into our region. So I just want to start to put this research into a little bit of context. And I really want to start with how we traditionally think about natural gas. We really think about natural gas as mostly methane. And methane, we know, is a really important climate pollutant. So we know the climate risks are there. It's the 2nd largest contributor to climate change. To meet a 1.5 degrees Celsius climate goal, we have to reduce emissions 4 times faster than at the rate that they grew. Methane reductions, interesting, can buy us time to do deeper decarbonization, but unfortunately, the research keeps coming out that the levels are still climbing. And Boston, as I mentioned, is not unique. 2.5% of the gas delivered to Boston is lost each year. The study came out 2 years ago, and they also showed that over the past 8 years, the concentrations have not been decreasing. And really, we're thinking about natural gas and climate change in the perspective that decarbonizing our built environment, the homes and buildings, is going to be especially challenging. There's a lot of sunk costs, and it's going to be a really difficult problem to tackle. And I think our study is hoping to bring about a new way to think about natural gas leaks, or at least a way that hasn't been thought of before. And that is thinking about natural gas leaks as perhaps an air quality impact and a direct health impact as well, in addition to the climate impacts. So really, this study reveals that there's a previously unaccounted for source of hazardous air pollutants or air toxics in natural gas that's delivered to our homes and businesses. Now, as I mentioned, we didn't formally study leaks, but when we enter a home, we have a methane detection device, and sometimes we do find leaks. And we found that about 1 in 20 of the homes that we were in the Greater Boston area had a leak that required fixing. This has been something that has been similar in some of the other cities that we've been to as well. So we do think that leakage is occurring. And therefore, we can say because there is leakage, we know there's at least some exposure happening, and the health risks are not zero, but they're likely on par with many other indoor sources. But I just do want to caution, we really didn't study exposure And therefore, we can't definitively say what the health impacts are. But we also know that leakage is occurring out in our streets, in our cities, in other places, and there's 10,000 known leaks in Massachusetts alone. So this is certainly contributing to outdoor air quality impacts as well. Many of these chemicals that we measured, they can transform into other pollutants that we know are health damaging as well. So now I want to pass it over to my colleague, Dr. Kurt Nordgaard, to provide a bit more context on how we think about exposure and health and some of the limitations of our study.
Great, thank you, Drew. So I want to start off by addressing the question that I think most of us are really interested in after hearing about the results of the study, and that is, does this mean that using natural gas in my home is making me or my family sick? And we have to start off by appreciating, like Drew mentioned, we can't really answer that question, even if it's a very interesting or important question. We can't answer it based on this study alone. What we can say is that in order to get to that question, we have to march through the science, starting with this study to show that actually natural gas does contain harmful air toxics or air pollutants in it. And so, of course, we also want to have a simple yes or no question. Is natural gas bad for my health? Yes or no? And that's not quite how public health works. So we think about risk, health risk. What's the health risk of these compounds being in natural gas? As Drew said, the risk is probably not zero, just based on what we know about the chemicals we found in natural gas and their effects on human health. At the same time, based on what we've seen from our first study, we think probably it's going to be less than something that we know is a very serious health impact or health risk, like exposure to tobacco smoke. So given that, I do want to just say a little bit more about this point that Drew brought up, that this study we could consider a hazard identification study. And that's because for us to suffer some health effect from an environmental exposure, there's actually several pieces. There has to be a health hazard. The hazard has to be released into the environment, and then people have to be exposed to it. And so we did the first piece of this. We identified compounds in natural gas that would pose a human health risk if people get exposed to them. That by itself, even though it doesn't directly answer a question about health, is still very important, because prior to this study, there have been no published research studies on what is in natural gas that's being delivered to our kitchens. So this is the first time we've actually been able to understand that. And from here, we can go on and look at, well, how much are people being exposed to? So we did find, again, benzene in gas, very important because it's toxic even at low concentrations. And as Drew pointed out, there are a number of ways that we either know or suspect people are exposed to natural gas, and along with that, some of the compounds we identified. So whether that's natural gas leaking from appliances in the home, or perhaps workers in a commercial kitchen, or even pipeline workers who are exposed to natural gas leaking from a pipe that they're fixing in the street. So those are some of the reasons why this study is important. And the last thing I want to bring up is just, again, the implications for health, thinking about whether using natural gas in our home might be harmful for us. As Drew pointed out in the beginning of his presentation, we do know that, in fact, we have growing evidence that burning gas in a stove, especially unvented natural gas stoves, release multiple harmful pollutants into the air. So that's one category of health risk that we already have some evidence about, but the data between this study and other studies showing that natural gas appliances leak brings up another question of whether simply having natural gas in the home, having natural gas appliances in the home, might pose a health risk. And we still don't have the answer to that, but this study represents a very important step forward to answering that question. And of course, we'll have to do more research to really answer the question in the future. And with that, I'll pass it on.
All right. And I'm Zainab Magavi. I'm co-executive director of HEAT. And Dr. Nordgaard explained clearly what we don't yet have data to conclude, but what can we reasonably conclude with the data we do have? And what actions can we take based on that? And so the first one is that given that over 95% of pipe quality natural gas is methane gas, which does not have human toxicity. And natural gas produces less fine particles than diesel or oil when burned. Historically, natural gas has been described as a clean or cleaner fossil fuel. Now that we know there are small quantities of these VOCs described present in the gas supply, at least in the greater Boston area, it is reasonable to conclude that our gas supply is not as clean as many thought. So what do we do with that? Well, first, as Dr. Nordgaard said, let's learn more. We can increase data and transparency. Let's monitor and transparently report more detailed compositions of natural gas at multiple points along the system and really understand what is happening with this. 2, we can also reasonably reduce any potential health impacts through preventative measures. And of course, public health is all about prevention, right? And we can increase filtration and ventilation in buildings. And I know you've been hearing about that a lot because it also decreases the chance of COVID spreading. So that's a big win-win. And finally, and this is a bit obvious, finding and fixing indoor gas leaks or removing potential sources of leaked indoor gas or gas itself will also help to prevent any potential health impacts and improve safety. Another win-win. So since we're talking about gas leaks and safety, a quick moment of reminder. If you walk into your home or any closed space and there is a strong smell of gas, please be safe. Turn around, walk out, don't turn anything on or off on your way out, and from a safe distance, call emergency services. They will be able to assess whether the leak is large enough to be an explosion hazard. Which brings us to the second conclusion listed here. The smell of natural gas is added in amounts regulated by federal and state agencies as a safety measure so that you will be able to smell it long before it becomes an explosion hazard. So one of the interesting findings covered earlier was that sometimes the smallest leaks would not be detectable by the average human nose. What should we do with that information? Well, let's learn more. Increase data and transparency. I'm sure you're seeing a theme here. And there is already oversight of odorant levels at the state level, and none of the measures violated an existing regulation. But perhaps working together with scientists and utilities, we can understand better the seasonal variation that was observed. Second, the current odorant levels are set to ensure that a human can detect or smell gas at a percentage which reasonably ensures safety from explosion. We could consider adjusting the threshold to ensure safety from exposure once we have exposure data. Third, we can use more sensitive technologies that can detect the smallest gas leaks to survey homes to ensure there are no leaks. A licensed plumber or appliance installer may be able to provide this service. But that raises the question again, and our last item, what are the exposures? Is there a health safety issue where we hear that we need to address? Where are people getting exposed to leaked unburned gas? And how much? Is there inequity in that exposure? Does gas supply contamination vary in other cities or locations? Well, many are likely natural in origin. Where are these VOCs entering the gas supply? What is driving the variability? So like all good science, this study asks a question, and in answering it, which we're very excited to do, it both tells us something we didn't know before, and it raises more questions we need to answer. It also gives us a bit of hope that we can multi-solve some of the challenges we face, that we can address climate while improving safety and health in the energy transition ahead of us. So turning it over to Drew for final remarks.
Thanks, Kurt and Zainab. So a few closing thoughts here. So I just want to share a little bit of my experience in having stood in now hundreds of these kitchens, speaking with folks about climate and health, describing our study. And what's really fascinating to me about this backdrop is that it is both extremely familiar and yet can be oddly foreign if we just think about it a little bit differently. That is, a fossil fuel pipeline literally ends where the kitchen begins. It's a direct conduit to a gas well deep underground, really far away. And by far, this messaging was the most arresting of the ways that I tried to describe the study to participants. And I mean, you'd really see eyes light up, wow, I never thought that a pipeline ended in my kitchen before. And I think once that link is made, the conversations really scaled from there. And then they went in some interesting places that I didn't always expect. But I think that's because it's leveraging a really deeply ingrained familiarity. And all of a sudden it's introducing something unknown about it. But the scaling was really interesting. It would often lead to then, well, this is how your natural gas fired stove works. Your hot water tank and furnace, they work the same way too. And the conversations would get really interesting from there. And all of a sudden we'd be in the basement looking at the furnace or the hot water tank. So, having spent a lot of time talking to participants, and I really want to thank the participants. A study like this does not happen without gracious participants like yourselves. I hope some of you are out there listening, and thank you for inviting us into your homes in uncertain times for sure. So I think I'm pretty convinced at this point that cooking over a natural gas fired flame is probably the most intimate connection with climate change that we never think about. And I really think it can unlock other conversations that need to take place. And this is actually why we named our study, Home is Where the Pipeline Ends. So I want to stop there and again, thank all of the participants. I want to thank all of my co-authors and our funders who so gracious, the Barr Foundation and the Putnam Foundation. And of course, we had a large author list from multiple institutions. So I think we'll stop there and we can open up for questions, right?
Yeah, thank you, Drew. So we have a few questions coming in, and I will just start with a question that we got from Judy. Does gas also leak from boilers? Have they been studied? Drew, would you like to take that one?
Sure, yes. Gas certainly leaks from all appliances a little bit, probably just like the gas stove. They are designed the same way. They have to give a puff of natural gas across a flame, and then it has to ignite. So even when cycling on and off, these appliances do leak a little bit. Not all of them, of course, leak in a persistent manner. That is an operational state that we don't want, and it is something that means that it is malfunctioning, not working as intended. But that does happen, as I mentioned.
Thank you. The next question is from Susan. Are you able to disaggregate the findings by geographic environmental justice locations?
We were not able to tackle that really important question here, in part because we originally thought that it didn't matter really where we sampled the natural gas stream from. We thought that the natural gas stream would not have variability across space. It is the same natural gas pipeline that is flowing down the street, flowing throughout the city, really shouldn't see differences by communities, even though we did see differences by communities. So this is something that happens in science where your assumption is wrong. And so we need to further explore, are there potential important factors then that are potentially driving those differences? And if we can understand those, well, then we can maybe talk about, okay, how do we design solutions to address those differences?
Great. Justin asks, can you speak to where benzene and other toxics might come from and what it means for how the findings of this study can apply to other gas service areas? Zainab, I know you touched on this a little bit.
Well, I'll let Drew take it as well, but benzene, toluene, ethylbenzene, xylene are all known to be present in the natural gas supply from it at the very beginning during production or fracking or conventional production. Any of them, the source of natural gas underground is known to contain many of these compounds. What wasn't known is whether they were actually making it all the way to our homes. And there may be as well there's a large number of compounds identified, and there may be many of them entering at other points along the supply chain. And that's, again, a study. We have a long list of, we did not sample all along the gas system. So Drew, anything to add?
Yeah, just to say that, like Zainab said, a lot of these vault organic compounds, which is the technical term of class of pollutants that we looked at, they are naturally occurring. There are also man-made sources. We could really not do what is called source apportionment, which is trying to figure out where is this coming from. Just because it's really difficult to know if you sample in a home, where's that gas coming from? It's probably coming from a lot of places. It's heavily mixed by the time it reaches a home in New England. And I just also want to stress the one point that Zaina mentioned as well, is we only measured this one class of pollutants. That isn't to say there aren't other classes of pollutants worth looking at. And again, you really only know what you measure. So I think part of our goal here is to try to think about, are there other trace gases in natural gas? It's not just a homogeneous methane only commodity. So yeah.
Great. And then we have a question from Naya. Did you find anything that indicates whether older gas stoves are more likely to leak?
So again, because we did not look at leakage that was outside of this study, I can comment on this because our colleague at PSE, Eric LaBelle, led the study of the 53 stoves and ovens and how much they leak, and they could not find a difference with age. There was not any kind of trend with older or newer stoves, whether or not they leak more or not. So I will say the leaks that I have experienced in walking into homes, that seems to be my anecdotal small sample size of evidence. Sometimes it's a very old stove. That certainly has happened. There's a lot of wear and tear. That makes sense. But also I've seen brand new installations of appliances that also can leak as well. So certainly more information is needed there to try to better understand.
We also have a question from Kathleen that asks, in relation to identifying a previously unidentified environmental hazard in homes, wouldn't the health risks from contaminants in natural gas be expected to be additive or perhaps cumulative with existing hazards? Drew or Kurt?
Yeah, that's right. That's a very astute question. So the compounds we identified in natural gas, for a lot of them, are not unique to natural gas. There are other sources in the home, and the number one source would be combustion. So again, smoking cigarettes in the home is a very important source of benzene in the home. But the outdoor air also contains some level of benzene, and outdoor pollutants in the outdoor air are able to migrate into the home. So between the things you have in your house and the outdoor air, yes, there is likely some background level of these pollutants. And having a natural gas leak and leaking these air toxics into your home is additive. And so if we think about some of these having a set regulatory limit to determine what might be safe, if you have some background exposure and on top of that you have some exposure from natural gas leaking in your home, then that may push the air quality in your home from what might be considered safe to something that might pose a health risk. In terms of a multiplicative effect, there is some research on the combination of chemicals, but we actually don't know what it means to be exposed to 10 or 20 of these air toxics altogether. And so that's really something research hasn't tackled. We tend to try and categorize these compounds individually so that we can isolate them and determine what's the unique effect for a given air toxic. So that's really an open question as well.
Great. So Andrea asks, are many of the stove leak emissions as the stoves are working as designed? Leaks sound more like an accident.
I would say there's certainly some leakage that occurs by design. As I described before, the way that a gas stove works is you turn open the valve, 100% natural gas comes out, which is around 95% methane. That natural gas has to mix with the ambient air and actually get to the upper explosion limit of methane, which is 14%. So you really need this kind of Goldilocks zone then of between 4 and 14% methane, and then ambient air alongside it. You need oxygen to fuel that flame. So I'm sure all of us, that characteristic click, 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 before that natural gas has mixed enough with the ambient air, the ambient kitchen air, and brought that level of methane down to a point where it can be combusted. So same happens when you turn your stove off. There's a little bit of gas that escapes. That's just how the gas stove works. That's also how your furnace works. That's how your hot water tank works. They all kind of work the same way. And of course, the leakage that occurs that is not related to use, if it is just sitting there leaking, that is not by design. Those are leaks that we don't design into the system. We don't want those to be leaking. And again, I'll just reiterate, getting a leak check by a certified professional is an easy way to verify that you don't have a leak in your home. It's a really easy thing to do. And I would recommend that because some of the leaks that I experienced in homes, sometimes I didn't smell them either. Sometimes I do. There's a lot of competing smells in the home. And so, yeah, I think getting a leak check is certainly something. And at the end of the day, it's gas that's being leaked into your home that you're not using, but you're still paying for.
And I'd love to just add that given the challenge for people who rent in potentially having their landlords get a leak check or paying for it, one thing to consider might be, for example, having any transfer, real estate transfer require a check for leaks or some other possibilities like that.
Great. Okay, so we have one question that is on follow-up research from this study. And Drew, maybe you could speak a little bit to the research that PS is doing moving forward.
Right. So great question, because there's a lot of ongoing research happening that's trying to better answer some of the new questions that have arisen from this initial study. And so as I mentioned, this is really just trying to figure out whether or not there's a hazard present. we really need to get a better idea of exposure. That is, we need more data on leakage, and then we need more data on how much of that is actually getting into our lungs. And then we can get a better idea of estimating health risks here. And so we've actually been sampling gas the same way in a lot of other US cities. One of the questions we first had is it different in different cities? What if you live closer to an area of natural gas production? The gas perhaps hasn't traveled as far, hasn't went through different phases of storage. So we've been sampling in dozens of other US cities. And so those studies are under review right now. And the other related research we're working on is actually trying to figure out if there's other pollutants when gas is being burned that we haven't thought about, because really those pollutants can get pretty high when we're using a stove or oven. And if it's unventilated, can be a pretty large source. So yeah, those are really the questions we're trying to hone in on, and really thinking more about natural gas and health and climate in the home.
Great. Thank you. And thanks everyone for the great questions. I think we tried to get to most of them today, but I think we'll end here. I want to share that for those of you who registered, we're going to send out the presentation and a recording after the fact. And if you'd like to hear more from the wonderful panelists that assembled here today, the Boston Globe will be holding a Twitter space on Thursday. And so head on over to their Twitter profile, to the Boston Globe, and sign up for that Twitter space. We'd love to see you all there. I think besides the researchers have been shared in the chat. And besides that, thank you all so much for joining.
Thanks, everyone.
Thank you.
Thank you all. Bye.